The next topic is trigonometry. In trigonometry, candidates should be able to calculate the sine, cosine, and tangent of angles between minus 360 degrees when theta lies between minus 360 degrees and 360 degrees. Point number 2. Apply these special angles, e.g. 30 degrees, 45 degrees, 60 degrees, 75 degrees, 90 degrees, 105 degrees, 135 degrees to solve simple problems in trigonometry. Then point 3. Solve problems involving angles of elevation and depression. Remember, from our residual knowledge, we know that the angle of elevation is equal to angle of depression because there is a line of sight separating the two angles. What am I saying? You have a boy somewhere here looking at a palm tree. Meanwhile, this is the horizontal level. So the angle of depression is usually somewhere around here, coming towards this end. Then you have our line of sight. This is what is known as what? Line of sight. Meanwhile, this angle is the angle of what? Elevation. So you can see it is going upwards. From the word elevation is going upwards, while from the word depression is coming down. So if this place is theta, this place will definitely be theta. That is why we always say that angle of elevation, this is angle of elevation, angle of elevation, and this one is the angle of depression. So that is the relationship between angle of elevation and angle of depression. There are also solve problems involving bearings. Point number 5. Apply trigonometric formulae to find areas of triangles. Solve problems, that's point number 6. Solve problems involving sine and cosine graphs. There are 15 UTME questions designed for this topic as shown in figure 1.6b. So the first question says, find the value of x. We are given a triangle like this, such that we have two known angles. Even the third angle can be calculated because we know that the sum of angles in the triangle is added up to what? 180 degrees. But look at this. The side x, the angle facing it is here. Meanwhile, the side 30, the angle facing it is this. So there are conditions for using cosine and sine rule. If conditions for using cosine rule, two sides and an angle not included. That is the condition for using cosine rule. Then the condition for using sine rule, this is cosine rule. Conditions for using sine rule, this is cosine rule. Sine rule is that two angles including at least a side must be given. So in this situation, which one will now suit this question of interest? It will be no other one rather than what? Sine rule. Because in this situation, two angles are given, but one of the angle is including a side. You can see it, the side is known. So in that situation, we use sine rule. So by using sine rule, we will just say, sine rule is saying that A over sine A is automatically equal to B over sine B. In this regard, we can say X over the angle, sine of angle facing it, that's sine 60 degrees, equals to 10 centimeter over the angle facing it, that's sine 30 degrees. Now in this situation, if we look at our option, we discover that our options are left in short form. That means we have got no other choice rather than to use what? Special angle. And by virtue of such special angle, know that x sine 60 degrees by special angle is root 3 over 2, which equals to 10 centimeter. And sine 30 by special angle equals 1 over 2. So in this situation, we can now simplify this. So we have x times 2 over root 3, because once this division takes to multiplication, then this one will be reversed, equals to 10 times 2 over 1. So 2 times x, 2x root 3, equals to 2 times this 20 over 1. So what do? We cross multiply. By cross multiply, 1 times 2x, 2x. 20 times root 3, that's 20 root 3. And we are looking for our x. What do we need to do? We divide both sides by 2. We divide this one by 2. We also divide this by 2. Divide this by 2. 2 here 1, 2 in 10, and 20, 10 root 3. 2 here 1, 2 here 1. So our x will be 10 root 3. And that is our answer. 10 root 3 centimeter. So we go to our option and see the one that matches that, and that is option D. Then the next question says that in a right angle triangle, if tan theta equals 3 over 4, what is cos theta minus sine theta? If you are to handle this kind of question, the first thing we need to do is to draw a right angled triangle. That's the first thing we need to do. We draw it. This is a right angle triangle. Then we can now choose. This one is fixed. We can choose our theta, either this or this. But for my own, for convenience, let me choose this as my theta. This is my theta. So if I'm saying tan theta equals 3 over 4, what it means? What is tan? Tan means toa. Toa means what? Opposite over adjacent. So in this situation, to this angle, this is the opposite. And what is our opposite? 3. To this angle, this will definitely be what? Adjacent. Why this is what? Hypotenuse. So in this situation, we result into the use of Pythagoras Theorem. We know that we can label this place A, then we label this place B, and we label this place C. And by virtue of Pythagoras Theorem, it's saying that the square on the hypotenuse here is AB squared, must be equal to the sum of the squares of the two other sides. So I can say this plus AC squared. So that is what it's telling us. So in this situation, our interest is to look for what? The hypotenuse, which is AB squared. What is our BC squared? BC is 3, so 3 squared. Plus what about AC? AC is 4, then 4 squared. Then that's what? 3 squared is what? 9. 4 squared is what? 16. So we have our AB squares to be what? 25. Then our A line AB will now be equal to what? Square root of 25, which is now what? 5. That means this place, which is our AB, is now calculated to be what? 5. So take note of that. Are we to stop there? No. The question asks us to solve for what? Cos. We are to look for cos theta minus sine theta. So we do it stepwise. We are looking for cos theta minus sine theta. Let's look for cos theta first. Cos theta is k. What is k? Adjacent over hypotenuse. So what is our adjacent to this angle? It is this one, 4. What is our hypotenuse? 5. So that means our cos theta will now be equal to 4 over 5. Then sine theta. Sine theta means so. What is so? So means opposite over hypotenuse. What is our opposite to this angle? The opposite is 3. What is our hypotenuse? Our hypotenuse is 5. So definitely we've been able to find a fraction for both cos theta and sine theta. Let's now go to our question, which is cos theta minus sine theta. So what is our cos theta? 4 over 5 minus sine theta 3 over 5. Then we look for the LCM. What's the LCM in 5? 5 in 5, 1. 1 times this is 4. Minus 5 in 5, 1. 1 times this is 3. So we have 1 over 5. So cos theta minus sine theta will be equal to 1 over 5. So we go to our option and pick the one that matches that. And that is option B. the next question, which is question 3. If angle theta is 135 degrees, evaluate cos theta. Take note of this. This one is testing what is known as what? Cast. It's testing cast. What is cast? C-A-S-T. Now, what is the meaning of C? Cos. Cosine. What is the meaning of A? All angles. What is the meaning of sine? S? Sine. What is the meaning of T? Tangent. Now, know that theta lies between 0 and 90 here. So all angles are what? Positive at this region. Here, theta lies between 90 degrees and what? 180 degrees. What is the, so it is only sine is positive here, only sine is positive. Every other one is negative, and the formula is 180 minus theta. So theta is lying between 90 and this. Then here, theta lies between 180 degrees and what? 270 degrees. So this one is theta minus 180 degrees, and in this respect, it's only tangent that is positive. Then the last one, theta lies between 270 degrees and what? 360 degrees. The formula is 360 minus theta, and it's only cosine that is positive here. So now, by virtue of what we are given our theta to be what? 135 degrees. If you look at this, my analysis, where do you think the 135 degrees will fall? The 135 degree will fall on the second quadrant, because it is on the second quadrant. This is the second quadrant. First quadrant, second, third, and fourth. So it is on the second quadrant that our theta lies between what? 90 degrees and